Let's relate local extrema to derivatives. Let's look at a function that has a few local extrema. So this could be some sort of polynomial. It has a local maximum here, here, and here. A local minimum here, here, and here. And if we draw in the tangent lines at each of these 6 local extrema, the tangent lines are all horizontal, and horizontal lines have slopes of 0. Therefore, the derivatives at each of these points is 0. Let's state that as a theorem. If C is a local extrema and the derivative at C exists, then the derivative at C is 0. A few comments to be made about this theorem. First of all, here is a function that has a local extremum, a local minimum, but the derivative here is not 0. The derivative does not exist. Hence, this requirement. Second comment, f of x equals x cubed. F prime of x is 3x squared at x equals 0. The derivative 3 0 squared is 0, and yet this is not a local minimum or a local maximum. So if we have a local extrema, the derivative is 0, but we can't go the other way. The derivative being 0 does not mean we have a local extrema. However, we can say, based on the comments we just made, that if C is a local extrema, then either the derivative does not exist, or if the derivative does exist, the derivative is 0. We'll collectively define the critical values of a function to be the numbers C such that either f prime of C does not exist, or f prime of C equals 0. This theorem then says that if C represents a local extrema, then C is a critical value, but not vice versa. I'm being slightly sloppy with my terminology, by the way. A local extrema is really a point. I shouldn't say things like if C is a local extrema, but I hope that's not causing confusion. What I really ought to be saying is that if C, comma, f of C is a local extrema, then one of these things is true. Later in the course, we'll address this issue. How do we decide whether a critical value represents a local extremum? But we won't do that just yet, and we don't need to know the answer to that for our goal of finding absolute extrema. So in this video, we've seemingly gone on a detour, but in the next video, we'll see how we can find absolute extrema, and the method involves critical values.